In 5.1 to 5.4, we have been reviewing a lot of probability from Chapter 4. We've also looked at different types of random variables and binomial distributions. So diving right in to start off, we are going to identify different scenarios as either a discrete or a continuous random variable. So by definition, looking back at 5.1, a continuous random variable has numbers with decimals. Discrete is going to be a whole number only. So looking at number 1, you're dealing with the area of land covered by a local high school. When you're calculating area is one of those where you can get decimals, so that is going to be a continuous random variable. Whereas in number 2, the number of students in Centennial, you can't have part of a person, so those are going to be whole numbers and discrete. And then on number 3, we're talking about the weights of steers at the Fort Worth Stock Show. Weight is another one like area where you can get decimals, so that will be continuous. All right, looking at the next set of data, we are defining Y as the number of pets a student has at a local high school. Suppose you choose someone from the high school at random. The probability distribution of P is as follows. Okay, so looking at this, we have Y value. Our Y values are whole numbers, because you can't have part of a pet, and then our probabilities are all in decimal form, which they are all between 0 and 1, so looks good so far. All right, so since Y is number of pets and it is whole numbers, we are going to say discrete, because you can't have a part of a pet. And then using that same data, looking at number 5, okay, we're going to determine if or whether or not this is a valid probability distribution. Okay, so looking at A, okay, is each probability between 0 and 1? We've already said yes, okay, just a second ago. Do they all add up to 1? If we were to take and add the 0.02, the 0.25, 0.35, 0.2, 0.1, and 0.08, yes, they do all add up to 1. All right, so since both of these are yes, then our probability distribution is valid. Okay, if one of these was no, this would be no. Okay, they both have to work for it to be valid. If one of them doesn't, it's no longer valid. And you had one like that on your progress check. Okay, so looking at number 6, we're wanting the probability that the randomly selected student has at least one pet. Okay, so I'm going to go back to this. We're wanting at least one, so we're wanting 1 or more. So you're wanting 1 through 5, so we can either add these up or you're not wanting the 0. Okay, so 2 ways you can work this. You can either add those up, which is going to give you 0.98, or you can subtract what you don't want from 1. So subtract that 0.02 and it will still give you 0.98. Whichever is best for you works for me. All right, and then in number 7, we're looking at what the probability of Y greater than 2 means in words and what's its probability. So Y greater than 2 means that you want pets, students to have more than 2 pets. Okay, so we want the probability the student has more than 2 pets, and then in order to find that, I'm going to add my 3, 4, and 5 because you're not wanting 2 or less. Okay, so adding that probability for 3 pets, 4, and 5 or more, which is going to give me the 0.38. All right, and then in number 8, we're calculating the expected value. There's 2 ways you can do this, and on the next couple, not necessarily with the same data, but there are 2 ways you can do it. You can go to that Omni calculator and find it, or you can plug it into Staplet under the discrete random variables. Click on this discrete random variable on that front page. It'll take you to this one. Type in those values, hit begin analysis, and then it will give you your graph as well as your mean and standard deviation. Your mean in this case is that expected value for the discrete random variables, and so the 2.35 is what we're looking for in this case. Okay, otherwise you would take and you would multiply every value by its probability and then add them all up if you were doing it by hand. We like technology, and so we use it to our advantage, so we don't have to calculate all of that by hand. All right, in number 9, we're interpreting the expected value for number 8. There may be a typo on your page. I had moved some numbers around. I think I forgot to edit it. So we are interpreting the expected value of that mean from number 8. So the underlined part is the part that you really need to remember. If many students are selected, we expect them to have about 2.35 pets on average. Now remember, when you're interpreting the mean or the expected value, the only value you're going to have in it is the mean. Okay. However, on number 10, we're interpreting the standard deviation, which is that 1.236. Okay, when we're interpreting standard deviation, we are going to have both the mean and the standard deviation in our interpretation. So in this case, we would have the number of pets would typically vary by about that standard deviation of 1.236 pets from the mean of 2.35. Okay, so you have the variant, which is your standard deviation, and then your mean on the back. Okay. So in the next part of stuff, we are looking at a free throw, like a free throw percentage, like that was similar on your progress check. Okay, so in this one, Lana makes 85% of the free throws she attempts. At practice, each player shoots 50 free throws. Okay, we're defining X as the number of free throws made. Okay, so when you're dealing with stats like this, whether it be basketball, baseball, soccer, whatever, okay, you don't update your percentage after every single shot. You take each practice, each game, whatever, and you calculate it at the end of it. So each game per se is its own trial, and then you update as you go. Okay, so in this particular case, 85% is what we're going to be looking with. All right, so we are going to determine in number 11 if X is a binomial variable. So it has to mean, in order for it to be a binomial variable, we have to have all 4 of these work. Okay, so on the binary part, we have a success as making the free throw, and then a failure is missing the free throw. So in binary, all we're doing is defining which is which. Okay, is it independent? Yes, because knowing the outcome of one free throw does not affect the next free throw. So if you make the first one, that doesn't mean that you're going to make the second one, and vice versa. Just because you missed the first one doesn't mean you're going to miss the next one. Okay, so each shot is its own independent situation. Okay, so our number is that 50 free throws. So we're going to define N as 50. And then does each shot have the same probability? Yes, because we're not going to change it after every single shot. Okay, so I'm going to take that percentage, and that's going to be my probability in decimal form. Okay, so does it meet the requirements? Yes. So it is a binomial setting. If you're independent, these are the things to watch. If you're independent or your probability was a no, if it's non-independent or if it has a different probability, like in that playing card situation in our notes, then it would not be a binomial setting. Okay. So continuing with that free throw stuff, we are going to calculate the mean using the formula for binomial random variables. Okay, so our mean is just our N times P. So the number of free throws times our percentage as a decimal form is that 42.5. And then for standard deviation, we have a formula for it. Okay, so if we're plugging it in Desmos, you can plug in that 15.85 and it will spit out the answer. This is why we like Desmos. Does it for us. So we have a mean of 42.5 and a standard deviation of 2.52-ish. Okay, side note. You can use Statlet to calculate these. It's under that binomial distributions. Okay, which we'll look at in number 14. Okay, so you can go to binomial distributions and plug in your mean and your probability, and it will calculate these for you. Sometimes Desmos is quicker. It just depends on internet and which you prefer to use. All right, so looking at 14. Okay, 14, we are going to use the binomial distributions because we want that graph on this one. We're graphing that histogram. Okay, so on the front page, or that first page of Statlet.com, you'll go to the binomial distributions under probability, and then you will take that 53 free throws that you've defined at number 11 and the 0.85, and when you hit plot, it gives us our graph. Okay, so looking at this graph, okay, you have a little bit over here, but not a whole lot. Okay, the rest of it is fairly centered. Okay, so we're going to call this shape somewhat symmetrical. Okay, although we do have a little bit of a tail over here, it's not enough to really skew that that graph. Okay, so for the most part, we have a somewhat symmetrical graph. Okay, there will be a graph on your test, so be familiar with your shapes and which direction it goes as far as skewness if you have any. All right, so on number 15, we're going to use that binomial probability formula from 5.3, I believe, and Desmos on this one to calculate finding, making 45 free throws. Okay, so from your notes, okay, when you're typing into Desmos, this is exactly like you type it. Okay, commas, the NCR, the whole kit and caboodle. Okay, the only thing you're putting in, the NCR stays out front. Okay, the only thing you're putting in is the numbers in the N, R, and this, the rest of it on this side. Okay, so when I type that in, okay, I'm going to replace my N with 50, my R is at 45, and then the 0.85 is my probability. 45 is what we're looking for, and then 1 minus that probability with 50 minus 45. Okay, so when we plug it into Desmos, okay, literally typed in just like it is right here. So your NCR stays, your N and your R on this side with your P, those are the numbers that change. Okay, so Desmos, you don't have to simplify this. Okay, sorry. But I will say if you're putting your exponents up like that, it will require you sometimes to put a parentheses around your exponents. So watch that when you're typing in, if you're typing it in that way it doesn't mess up your calculation. Okay, so you can use Staplet again to find your probability. That binomial distribution, we've already, if my stuff would cooperate today, we've already typed in the N and the 0.5 from previous problems like this here. And so it will give us mean standard deviation. When you're looking for exactly 45, okay, under that graph, it'll have this area right here. You'll put exactly 45 because that's where that equals comes from. And then when you hit go, it gives us a percentage. Now notice, I'm going to go back. Okay, notice this is in decimal form, which is your probability. Okay, and then in this one, it gives us in percent form. Okay, on your test, generally speaking, I'm looking for probability in decimal form. Okay, the only time that we really use that percent is when we're interpreting it. Okay, so be sure that when you're calculating stuff, if you're using Staplet, be sure you change it to decimal form when you're typing it into your answer on your test. Okay, so looking at number 16, and I say that because we're fixing to interpret the value. All right, so answer found in number 15, okay, right here we say that there's a 0.102 probability. Okay, this part you can make into the percent. Okay, so if it's the probability, if it's decimal, we put probability, and then obviously if it's percent, you put the percent sign. Okay, depending on how you're wording that. Okay, so we have a 0.1072 probability of her making exactly 45 out of 53 throws, or a 10.72% chance of her making exactly 45 out of 53 free throws. Words are hard today, apparently. Okay, so on number 7, Coach says that he will let the team out of practice early if she makes 40 or more. Okay, so what's the probability that practice ends early? So in this particular case, we're going to assume that she makes the first 40 free throws. Okay, so 2 ways to work it. Okay, we're going to look at Desmos first. Okay, so we're looking for exactly 40. So same way we just did in number 15. Okay, I'm going to plug in that the number of free throws that we're shooting, the number that we want, then our probability, number we want here, and then we are 1 minus your probability, and then the 50 minus however many you want, which is going to simplify down to 10 when we plug that into Desmos. And one thing I like about Desmos, if you've already got it into Desmos, the only thing you have to change is that R value and then your exponents up here. Okay, so again, it gives us in decimal form. So we have 0.0889. Okay, and then if you were to change that percent, if we do it on Staplet, okay, exactly 40, change this, okay, and then it gives us our answer in percent form. Just remember on the test, in most cases, I'm looking for decimal. Sometimes I even put in decimal form. So be sure you read to see which it's actually looking for, and be sure you put it in the right one. Okay, so pay attention to those details. It's going to start coming into play. So if you put it in Staplet and it gives you decimals, be sure you type it in, or gives you percents, be sure you type it in decimals on your test if that's what it's asking for. Okay, so that wraps up our review. If you have any questions or if you need more practice, let me know, especially where Staplet and Desmos are concerned. Sometimes those can get a little confusing on these drop downs when it's looking for exactly or at least, at most, whatever. So let me know if you have any questions, and we can go from there.